So, hello everyone present here in person and everyone watching this live. Good afternoon and welcome to this session. Today, let's look at Unity catalog migration and adoption at scale through the data journey of Adidas. I'm James, Resident Solutions Architect, part of the awesome professional services team here at Databricks. I have a background in data engineering and data governance, and I led the technical team who was responsible for the Unity catalog upgrade journey at Adidas. Given the scale of Adidas, it was an interesting and moreover a very satisfying challenge, during which I had the pleasure of working with my co-presenter, Shweta Patnaik.
Thank you, Jins. It was a pleasure working with you. Hello, everyone. My name is Shweta Patnaik, and I'm representing from Adidas as the Director of Platform Engineering and Operations. In my role, I lead a team of highly motivated DevOps engineers who build the Lakehouse platform with infrastructure as code automations. And I'm also leading a global Lakehouse operations team with the most talented data ops engineers. Today, it's my pleasure to address this audience and discuss how Adidas is adopting Unity Catalog at scale. Please stay tuned as we will share very informative insights into our Unity Catalog upgrade journey alongside partnering with Databricks. All right, so we have an exciting and a comprehensive agenda lined up for today's presentation. We will start by diving into the evolution of Adidas data strategy. We will look into the overview of Databricks Unity Catalog, and right after, we are going to discuss the differences between traditional AWS Glue architecture versus the Databricks Unity Catalog. Moreover, we will also see the Unity Catalog upgrade journey of Adidas from the lens of Databricks. We will share the impacts that Unity Catalog brings at scale. And finally, we'll see what our data leaders at Adidas talk about Unity Catalog. Coming to the Adidas data journey, you might ask me now how many data systems Adidas used to rely on for its data-driven decisions, how Adidas's data journey looked like. So let's take a quick overview. Earlier, before 2021, like any other big-scale data-driven companies, Adidas also had data challenges. Redundant data leading to inconsistent data insights. We built and utilized multiple data platforms with millions of euros invested across different tool stacks to fulfill our different business needs of global versus market local use cases. Additionally, there was a separate platform altogether dedicatedly created to cover our advanced analytics use cases. In 2021, Adidas started migrating to Databricks to unify all its data and AI use cases onto a single platform. However, governance for Databricks for access management and security models remained decentralized, relying mostly on AWS Glue and IAM roles. As against now, in 2024, we already have Unity Catalog technically live, trying to provide centralized governance for all data activities within Databricks. This is surely expected to providing Adidas a cutting edge in ensuring streamlined access and security. Plus, I'm sure it will significantly improve our data operations in the future. And now let's take a look how Adidas has grown in its Lakehouse adoption. Currently, Adidas has a big data volume and usage of 5 petabytes of data. This substantial volume of data underpins our analytical and operational processes. Our Lakehouse platform is hosting more than 270 data products with a big 4-digit sized active users community, leveraging these products for various analytical needs. Our Lakehouse data operations team monitors more than 1,200 production-grade data pipelines to ensure smooth data flow and integrity across our systems. They are also monitoring 96 machine learning models. We have 50 plus BI products that are live and in use across the globe with big, wide, active BI users community, providing critical insights to our different business functions. We have been able to successfully migrate already 70% of our data from legacy platforms, significantly modernizing our infrastructure and scalability using Databricks. Our lakehouse infrastructure is interconnected with 90 upstream and downstream systems, providing comprehensive data integration standards. So, what is the real state of play in Adidas right now? You might ask me this question. So, in reality, Unity Catalog is currently under adoption at Adidas on a full-blown productionized lakehouse platform. We kept talking for the last few minutes a lot around Unity Catalog. And now, let's hear it from Jins, what Databricks Unity Catalog is all about and why it is so important in Lakehouse.
Right, so what is Unity Catalog, or what we lovingly call UC? I feel like I probably should skip this slide after today's keynote session, but anybody who did not really listen to it, I'll just recap it a bit. So Unity Catalog is a key component of Databricks Intelligence Platform, offering a unified governance layer, and as of today morning, it is also open source. Now, what do I mean by unified governance layer? Unity Catalog allows organizations to govern their structured and unstructured data, ML models, notebooks, dashboards, and files, or in other words, all of your data and AI assets on any cloud platform. This unified approach to governance accelerates initiatives while simplifying regulatory compliance. As you will see through the case of Adidas, Unity Catalog simplifies governance at scale, enabling different personas like data engineers or business users or data analysts to securely discover, access, and collaborate on trusted data and AI assets. Now, what else could Unity Catalog offer? So it also enhances security with fine-grained access control on rows and columns, while efficiently managing the access through low-code attribute-based access policies and scale seamlessly. And all of this by seamlessly integrating with your existing systems and data. It is also the foundational technology for many of the revolutionary features like marketplace, private exchanges, and clean rooms. Now, let's see how the Adidas Lakehouse architecture looked like before introducing Unity Catalog and how it looks like with the Unity Catalog integrated. In the pre-Unity Catalog world, we used AWS Glue as the metadata layer at Adidas. Databricks and other systems wrote data to S3, updated the table level metadata in Glue, and later whenever querying, got this metadata back from the Glue, right? And access policies to data sets were defined not in Glue, but rather based on each of the data products' needs using S3 bucket policies and IAM policies. Now, this was relevant only to the data residing in S3. For BI systems and ML artifacts, the access control was managed in its own respective stack like SageMaker or Power BI. So a typical workflow would look like this. User logged into Databricks using the existing identity provider, Azure Active Directory, and to enforce the access controls on data, a corresponding instance profile was attached to the Databricks cluster running the job or querying the data with proper Glue permissions. Now, note that the instance profile is attached to the cluster, and it doesn't really care which user is running the query, right? So when the cluster tried to read or write the data, the permissions were checked against the instance profile and verified. So, and then, however, the access to the job triggering this query was checked for the user running it through Databricks ACL, or let's say if it was used for an ML model training, then the access to the ML model which needed to read the data was handled separately. So I'm very sure this whole thing sounds familiar to at least some of you folks, right? As you can see, the governance was not unified across different data assets, and row and column level data access were missing. And that's where we introduced Unity Catalog. In the current architecture, the governance is unified using Unity Catalog. Any action a user performs is checked against the access control list defined in the Unity Catalog. Here, the access control is not just for the data, but for any ML artifacts, BI dashboards, queries, notebooks, or basically everything that you can think of in a data journey comes under the Unity Catalog ACL. Let's take the previous user workflow example. A user logs in using Azure Active Directory, and when the user tries to run a job, Unity Catalog checks if the user has permission to access that job. Then within the job, when it tries to read a particular table or a file within a volume, Unity Catalog checks the permission to those objects for the triggered user, like compared to the previous architecture where it did not really care which was the user accessing it, rather which was the system accessing it, right? So this is one of the major change. And then it can go one step further and see if the user has access to the rows and columns, not just the table itself, but the rows and columns which is accessed by the job. Now, if the output of the job is used for an ML model training, Unity Catalog also checks if the user has the right permissions for that. Since in Unity Catalog, the ACLs are enforced at a user level, there is no need to attach any instance profile or any mechanism at the cluster level to enforce permissions on the data. It also combines the access for all kinds of users using the data, be it a business user or a developer, something which lacked in the previous architecture. Now, let's hear from Shweta on what motivated Adidas to adopt Unity Catalog.
All right, here goes a sneak peek of what were the key driving factors for Adidas to adopt Unity Catalog. Talking about lineage, we get automated lineage for all kinds of workloads. The part our data engineers at Adidas love the most about lineage is that it is tracked across all Databricks workspaces. It is not confined to a single workspace. If I have an ad hoc query, or if I have an ETL job, or even if I'm using a Delta Life table, then the lineage is collected for all of this and reflected on the Databricks UI. Further, this information is possible to be extracted and viewed on external partner tools, like which in our case is Collibra. Collibra has a well-to-do integration with Databricks, where it hydrates the lineage service directly from Unity Catalog. Coming to the search functionality, our engineers are now able to do advanced search, like searching tables and tag-based searches, also in combination with object types. And the best part about the search feature is that it is now access-based search. It automatically adheres to your security models. Now the next one is really very cool. The AI-powered monitoring feature really helps our machine learning engineers to cover every step of the model development process. The auditing feature is also very helpful for our lakehouse operations team. They can easily see the system logs, user activities, and billing informations, including even our financial forecasts for the lakehouse platform. This will surely help our upcoming yearly budget plannings. And the most important UC feature for Adidas is delta sharing. As far as external data sharing is concerned, if we need to do a data egress and share it with our downstream partners, just imagine if Adidas wants to share its data to its downstream partners like Zalando, Deichmann, Foot Locker, be it any company. These are the perfect use cases where delta sharing is really easy and super powerful. And of course, that's not all. UC is the future for a data intelligence platform. Now that we covered what motivated Adidas to adopt Unity Catalog, Jins will walk us through the UC upgrade journey of Adidas from the lens of Databricks.
Given the scale of Adidas and its data platform, the upgrade required meticulous planning and involved different phases. We made sure that it had very minimal impact on the consumers and that the change was very seamless. At a high level, these are the phases that were part of the UC upgrade journey in the given order. Now, let's take a look at each one of them in detail. The first phase of the upgrade journey was inventorization. Now, why did we start with inventorization and assessment, and why is this important for the upgrade? Like you saw earlier, the data landscape of Adidas is massive. In such an environment, there is no way one person or a team have the complete overview about the various assets in the data platform, nor about the different scenarios we need to be aware of while planning the migration. For example, we needed to know how many managed tables were there or how many external tables were there in the DBFS route. And if there were any, see if these needed to be upgraded. And in Adidas's case, this turned out to be very important, as after contacting the owners of these types of tables, we learned that none of them were required to be upgraded for different reasons. Either it was test tables or the tables itself was not used. And this avoided us a lot of effort for the upgraded team. Now, this was only possible because we learned about all of this during the inventorization phase. We also saw how many global init scripts were used and planned to convert them to cluster scoped init scripts. And we needed to capture what all data formats were being used, be it Parquet, JSON, CSV. Given the size of Adidas, we had multiple of those file types. And the different cluster types in use, understand various metrics like the number of tables, views, functions, jobs, or storage locations, amounts of data, or a lot of these metrics, and to quantify the effort and timeline of the upgrade engagement. This also helped us in identifying areas where we needed automations. And to gather these metrics and do an overall assessment of the existing landscape, we used the open source tool Databricks Labs UCX. What's here on the screen is part of the assessment report for one of the environment at Adidas. As you can see, it has captured various metrics like discussed before and gives the UC readiness for various components, upgrade strategy for tables, and many other details. UCX is a comprehensive tool that can be used at various phases of the Unity Catalog upgrade journey. I'm not going into the details of UCX during this session, but I highly recommend you to check out the project in the official Databricks Labs page. Then comes the planning. Once we had the inventory of everything, it was time to plan what needed to be done and how it needed to be done. During the planning phase, based on the results of the inventorization and assessment, we dove deep into each scenario and mapped out the different stages of the upgrade process along with the rollback plan. We decided to go for a phased upgrade based on the data products, giving each data product autonomy on when to upgrade to Unity Catalog. The upgrade plan you see on the screen doesn't look very pretty, but blame it on my poor Autodesk skills. But this is the actual upgrade plan we developed for Adidas. This shows high-level overview of the individual steps within the upgrade process, and we further defined details for each of the steps. We put emphasis in delaying the involvement of individual data product teams until the later stages of the upgrade process, and we also kept everything ready for them to migrate using automations and centralized changes, which we will discuss in a bit. Now, based on this, we had a very clear understanding of what changes were to be made and how much effort it would take and which teams needed to be involved at each stage. Stakeholder communication were made based on this. This early communication and stakeholder buy-in was crucial, given Adidas is a pure data mesh organization with 270 plus data products spread across different business units and geographical markets. Then comes the landscape design. One of the first things in Unity Catalog implementation is deciding how the data is structured within Unity Catalog. Prior to Unity Catalog, in Glue we followed a two-level namespace design. Unity Catalog follows a three-level namespace design, namely catalog, schema, and table view or volume. So this allows us to better structure the data landscape and have clear separation between different environments, organizational structures, and data products. But one of the challenges with changing to a three-level design from a two-level design is that it requires code changes wherever the data is being queried using the table or the view name, right? This is a very minor change, but this can snowball into a considerable effort if we multiply this with tens of thousands of notebooks and queries, which was the case for Adidas. And of course, this could be automated in most parts with some effort, but we wanted to see if we can avoid this downstream changes completely if possible. So what did we do? Adidas already followed a well-defined structure and had different glue catalogs for each development environment and defined one database per data product. So we decided to follow the same structure within Unity catalog, that is, define one catalog per development environment, namely dev, test, and prod, and define the schema at the data product level. Now, you might still ask, Jens, but in the existing code, it's still written in a two-level notation, right? So, for example, select star from schema.table, but with a three-level notation, it should be something like select star from catalog.schema.table. Now, who's going to make this change? Don't you worry, I got it covered on this. So this is where the default catalog came into picture. By setting default catalog at the cluster level and the workspace level, along with two-way sync mechanism, which we will discuss a bit later, we completely avoided the need to change any of the code and thereby continued using the two-level notation. Then comes the centralized changes. The key to speed up any migration or upgrade project is to have as many automations and to lower the number of touch points. Our case was no different. We started on this phase in parallel to the planning and the landscape design phases by solving some of the tasks we knew were required no matter what. Now, this can be mainly classified into two categories: infrastructure changes and application changes. Infrastructure changes included any changes that were required to use Unity catalog, like workspace, group migration, creating metastore and storage credential or metastore attachment to the workspace, changes to the clusters and warehouses, or mapping and migrating existing ACLs. Now, we prepared and tested all of these changes beforehand and made sure that making this change didn't have any impact on any of the existing workloads or users. These changes were rolled out in phases so that when the data product teams were ready to upgrade, the changes were already in place, ready to be used. Application changes included various automation scripts like table upgrade scripts that avoided or minimized efforts by the end customers to do certain processes, the two-way sync mechanism, and testing and solving various possible scenarios or edge cases and document these with steps to take, and the global init script changes and changes to the lakehouse engine. Lakehouse engine is Adidas's own framework which provided various data lake functionalities like archival or deletion protection or data quality, to name a few, which helped to speed up the development process for the data product teams. It's a pretty cool framework. I would encourage you to check it out. It's an open source project. Now, why did we do all of this? The main objective here is to minimize the impact for end users. How did we go about it? It can be broadly classified into three streams or goals. First, the central functions. This included infrastructure changes and automation scripts like discussed earlier. We ensured zero downtime during group migration by pre-creating account groups, pre-syncing users, and using UCX for permission migration. And then comes the two-way sync, which we discussed a couple of times. So what is two-way sync? So basically, to maintain uninterrupted access to the latest data during the months-long coexistence of Unity catalog and glue, we implemented a bidirectional sync mechanism. This involved the sync command from Databricks to update the external catalogs in glue table schemas to the Unity catalog, and for non-upgraded tables, for the upgraded tables, we fetched the latest DDL from the Unity catalog and executed a create or replace command in glue. Automation of this syncing process was achieved through Databricks system tables and AWS CloudWatch events. The upcoming HMS Federation feature will further streamline this. Second goal was to reduce touch points. We made sure that there was necessary changes to cluster configuration such as access mode adjustments, instance profile restrictions, or other parameters which was required for Unity catalog adoption. Now, incorporating these into cluster policies meant that the data product teams only needed to update their cluster policy, not each setting individually. Default catalogs at the cluster and workspace level eliminated the need for code or query alterations to a 3-level notation. This also made it possible to roll out changes safely so that we could roll them back if something went wrong. Additionally, we utilized existing Terraform templates for rolling out other changes. And then finally, to have no data movement. Imagine if you had to migrate even a fraction of the 5 petabyte data in the Adidas lakehouse. That could be very costly. So minimizing the data movement, and in Adidas's case, almost no data movement, was something we focused on. By maintaining the current catalog design, we prevented data rewrites to new S3 buckets. And syncing external tables, a metadata-only operation, also helped avoid data movement. Usually, to upgrade managed tables, we would have to move the data, but by converting the managed tables in mounted storage to external tables before syncing to Unity Catalog, we avoided the data movement also for the managed tables. And the infra upgrade and jobs upgrade. So this is the part where the individual data product teams actually got involved, making the changes to the jobs and upgrading the underlying clusters. The infra upgrade for data products was rolled out in phases, and the upgrade cluster policies kept in place. Since Unity Catalog requires newer DBR versions, clusters were upgraded to latest DBR LTS version beforehand by data product teams. Data product teams were dependent on each other's data, but we abstracted out these dependencies so that they were able to do the upgrade in isolation. What do I mean by this? Take, for example, the two-way sync mechanism. It made it possible for each data product team to upgrade on their own timeline without worrying if their producer data product had already migrated, or if this migration will affect or break their consumer data product workloads. Now, once the data product teams were ready, they followed the upgrade guide outlining the changes required to be made, like attaching the new cluster policy or upgrading the lakehouse engine, and also adapting the code to be UC compatible. The code changes, for example, could include changing the mount location to Unity Catalog volumes, or replacing the RDD API or Spark context usage. And while the jobs were upgraded, downstream systems like Power BI or Colibra also changed their source catalog and repointed their queries to a UC-enabled warehouse. Now that we upgraded to the jobs to Unity Catalog, we don't have to keep both Unity Catalog and Glue running, right? So it's time to decommission Glue at this stage. The table sync will be in place until the full migration is complete. Once a data product is upgraded to Unity Catalog, we remove the permissions to Glue for that particular product to avoid accessing it accidentally and creating new data objects in Glue. And Glue will be cleaned up only once all of the data products are upgraded, and at Adidas, we plan to achieve this before the end of this year. So far, we took a detailed look at the whole migration journey from AWS Glue to Unity Catalog at Adidas. Now, let's hear from Shweta how Adidas is adopting Unity Catalog.
All right, the journey towards a unified data platform has been both exciting and challenging for Adidas. As we transitioned to a lakehouse architecture, we sought solutions at Adidas that would not just only improve the performance of the platform, but also empower our data users within Adidas. Databricks Unity Catalog has been emerging as a game changer. Let's explore the different user personas utilizing the lakehouse. Now, before we delve into the user personas at Adidas, let's take a quick show of hands. Who in this audience of data enthusiasts is curious to know how Unity Catalog helps different data users at Adidas? Quite some hands, no surprise. We see many data enthusiasts keen here to know the key benefits of UC, bringing value to our data users within Adidas. So, like any other data-focused companies, Adidas also has different data users, like data engineers, who who are designing and building scalable and repeatable data pipelines. Say, for example, for inventory management, for sales order. Even we also have machine learning engineers. They are designing, building, and maintaining machine learning and deep learning models, be it for inventory management, be it for size and fit use cases, demand forecasting. All these use cases are covered by the machine learning engineers. We have our BI users who are transforming data into reports. They are consumed by users and even executives of Adidas, be it for sales and margin, order book management, business on hand. There are different use cases. We also have our data analysts who analyze and interpret data using SQL or Python. They are supporting our business functions to strategize and help on business decisions. And lastly, we have our data discovery users who explore the data residing on the lakehouse with an enriched data shopping experience via Colibra. So let's spend the next few minutes understanding how Databricks Unity Catalog is revolutionizing our data management at Adidas. So for data engineers in Adidas, let's see how UC is bringing an enriching experience. UC is surely simplifying and unifying all the user accesses across different data resources. Truly, that's giving a fulfilling experience to all our data engineers. Unity Catalog is empowering our data engineers to share data with partners, having real-time access to the most current data. This is now possible without having to copy any data, so no data duplication, no data redundancies, and maintaining the data consistency at the same time. Additionally, Unity Catalog is providing out-of-the-box monitoring capabilities to our data operations team. It is supporting our data ops team with detailed monitoring and audit logs, ensuring adherence to both internal and external policies. Unity Catalog is enhancing the security and overall efficiency in managing and operating our data at scale. Further, it is giving all the audit capabilities to log all our data activities and is for sure helping to ensure a robust oversight and thorough review and compliance. Now it's time to see how Unity Catalog is bringing a good experience to our BI users community. While data is definitely the new oil, analyzing the data at scale for our BI users is another ballgame. Especially with exponentially large data volume and too many concurrent users, performance of the BI reports for our users is very crucial within Adidas. Our BI users have experienced slightly improved report execution times with Unity Catalog. So how is Unity Catalog proving to be having better performance in the report execution compared to the traditional AWS glue? This performance acceleration is possible in the report executions because query listing now happens faster than before. This definitely boosts the productivity of our BI end users. They are more focused on the insights rather than having to wait for the results. Unity Catalog is also empowering our BI users community with streamlined filtering policies. Whether it's a row-level security or a column-level security, users can now seamlessly apply these policies to tables and views. These fine-grained controls are ensuring that sensitive data remains protected while ensuring that efficient data explorations can happen. One of the other significant benefits is also that there is very less likelihood of any risk when exposing tables with sensitive information to your BI end users. Wondering how Unity Catalog is solving this? Unity Catalog is ensuring that only authorized individuals can access specific data, as the policies can be applied directly on a table level without having to create any additional views on top, thus reducing the chances of any inadvertent data exposures. Now let's see how Unity Catalog is helping our data discovery users at Adidas. Unity Catalog is empowering our data users to explore metadata seamlessly. Whether it's reports, tables, columns, or models, user can now discover data at their fingertip and can quickly navigate through the wealth of information, highlighting the data assets, purpose, context, and relevance. There is no more tedious searches, manual explorations needed. Unity Catalog just does its work. And that's not all. Unity Catalog is providing an end-to-end lineage. Users can trace data from its source to its consumption, ensuring full transparency and trust. Understanding the data lineage is always very crucial for our data users. Unity Catalog is providing the lineage across tables, revealing the dependencies and the relationships. Beyond discovery, Unity Catalog for sure is more than a discovery tool. It's a gateway to contextual insights. Our data analysts at Adidas can now jumpstart their work and accelerate analytics by understanding the data's context, lineage, and relevance. Let's explore how Unity Catalog empowers our data analysts to work smarter, faster, and with confidence. Object-level insights. Lineage is definitely the best one Unity Catalog offers. Our data analysts can now trace how tables, views, and other objects are interconnected down to the specific columns. Whether it's notebooks, dashboards, workflows, feature tables, files, or even queries, Unity Catalog provides transparency for all. Further, there is full transparency on the end-to-end lineage, which means impact analysis becomes super easy. When changes are occurring, our analysts can quickly assess the downstream impacts. They are like having a data GPS by their side. Next one is very interesting. UC provides now an Insights tab, which reveals the popularity of the assets. Our analysts can now easily spot which notebooks, queries, tables, or joins are frequently used. Data enrichment becomes a breeze, as they know which of the queries or joins or notebooks are most in demand. Our analysts are gaining real-time visibility to what matters the most. Not just this, Unity Catalog is helping to identify our data domain experts. Who is working with which specific assets? Who understands the nuances? Collaboration is becoming absolutely seamless when we know who are our domain experts. Now, it's getting even more interesting. Let's see how our data science and machine learning engineers are having their life easy with Unity Catalog. Well, our data science and machine learning engineers at Adidas are at forefront of innovation. They run complex computer vision projects dealing with non-tabular data assets like images, videos, sensor data, and Databricks Unity Catalog's volumes feature has been very, very transformative. It allows our digital consumers to seamlessly interact with these non-tabular data sources, improving their training performances. Whether it's training deep learning models or fine-tuning image classifiers, volumes accelerate their work. In the fast-paced world of analytics, real-time analytics, our digital consumers face critical use cases. They need to serve machine learning models in real time, be it for fraud detection or recommendation engines, or even content delivery. Inference tables enables efficient model deployment and helps evaluate model performances. With Databricks Unity Catalog, our ML users are gaining more confidence in the performance of the real-time models. For our advanced analytics and digital users, understanding model behavior and performances is paramount. Why did a model's accuracy drop? What caused the drift? Unity Catalog offers AI-based monitoring solution, and these solutions are providing transparency into the model behavior over time. Whether it's a concept drift, feature importance shift, or even an unexpected bias, our ML users are able to trace down the exact reason. And this is like having a data detective by their side. Here goes last but not the least. Let's see some insights from the data leaders at Adidas about the transformative potential of Unity Catalog. Our data leaders have experienced firsthand the remarkable impact that Unity Catalog has on our lakehouse platform. And I'm very excited to highlight their perspectives with you all today. Stefan Bass, who is our Senior Director of Data Platform, emphasizes that Unity Catalog is a game changer for Adidas. He says Unity Catalog will reveal unseen insights in lakehouse usage across hundreds of products and thousands of users. It will deepen our understanding of the platform's value, enable cost optimization, and ensure transparent governance around all data and AI artifacts. Stefan believes that Unity Catalog is not just about managing data, it's about unlocking the future possibilities. He foresees that it will pave the way for future GenAI applications to unlock the full potential of our data at Adidas. Now let's look from the perspective of Dmitry Lichnik, who is our director of Lakehouse architecture. Dmitry foresees that UC is going to immensely simplify our data access architecture and will maintain consistent experience for all the Lakehouse users. Carlos Costa, who is leading our data engineering stream, sees Unity Catalog as a key enabler for providing secure and streamlined access to data, making it possible for every data citizen at Adidas to engage with data resources seamlessly. Finally, Philip Keys, the director of AI and BI engineering, appreciates how Unity Catalog automates and enhances data lineage, making data more discoverable and easier to share, which is essential for scaling up all the data and AI initiatives at Adidas. In summary, the visionary outlooks of our data leaders at Adidas clearly reveals how Unity Catalog is integral to our strategic direction. Indeed, Unity Catalog is not just seen as a tool, it is rather seen as the catalyst for innovation and efficiency across our data landscape in Adidas. Coming to the end now, I would like to call it a wrap. And as we continue our Lakehouse journey at Adidas and strive towards data excellence, let's celebrate the impact that Unity Catalog brings our way. Adidas is very eager to unlock the full potential of Databricks Unity Catalog in the Lakehouse landscape. Thank you for having us here today representing the voice of Adidas at the Databricks Summit. I take the chance on behalf of the entire Lakehouse team and all the Adidas data citizens to share a big thank you to Databricks. Databricks definitely has greatly transformed the way Adidas data users interact within Lakehouse. And I'm sure we have more to go, specifically with the direction of Unity Catalog. I can't go without saying that Unity Catalog is the next big pivotal thing in achieving the Adidas's data and AI's democracy vision. Thank you everyone and have a nice rest of the summit. Thank you.